Welcome to Algebra 1, Unit 6, Lesson 15 Practice Problems. Select all of the quadratic expressions in vertex form. So as we look at this, understand what vertex form looks like. Vertex form is in the format of y equals a times x minus h squared plus k. And from this form, the vertex coordinates are h and k. H is your x value, k is your y value of the vertex. So now when we look at a, we can see that a equals 1, that's why it's not shown. H equals 2, and k equals 1. This is vertex form. Next, we can look at B. In B, it might help if you thought about it being written as x minus 0 squared minus 4. Now, this might help you see that A equals 1. That's why you don't see a number. It's just understood to be 1. H equals 0. So they just didn't write it because whether you write x squared or x minus 0 squared, it's the same thing. And then k equals negative 4. So this is in vertex form. Next, we look at C, and C is actually written in factored form, not vertex form. So C is not a correct answer. In D, it might help you if you thought of this as x plus 3 squared plus 0. Now you might be able to see that this is in vertex form, where a is understood to be 1, h is negative 3, because if you subtract a negative, it becomes addition, and k equals 0. So this is actually in vertex form. And then our last choice, E, is obviously in vertex form, where A is understood to be 1, H equals 4, and K equals 6. So A, B, D, and E are all in vertex form. If you have any questions about vertex form quadratic expressions, please use class time to ask for further clarification. Here are two equations. One defines function m and the other defines function p. Number 1, show that the expressions defining m and p are equivalent. So what you might notice is that m is in factored form and P is in vertex form. So to show that they are equivalent, what I can do is turn them both into standard form. So m of x equals x times x plus 6. X times x equals x squared. X times 6 equals 6x. And now I have standard form. P of x equals x plus 3 squared minus 9. That becomes x plus 3 times x plus 3 minus 9. X times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. And then we have the minus 9. Now when I combine like terms, I have x squared. 3x plus 3x is 6x. And 9 minus 9 is 0. And we can see that the standard form for both functions is the same. M of x equals x squared plus 6x, and P of x also equals x squared plus 6x. So we know they are equivalent. Number 2. What is the vertex of the graph of M? Well, remember that vertex form equals a times x minus h squared plus k. So in this one, that means a equals 1, h equals -3, and k equals -9. So the vertex is at the point -3, -9. And number 3, what are the x-intercepts of the graph of P? Explain how you know. Well, since P of x and M of x are equivalent, then I'm just going to use the factored form, which is x times x plus 6. I'm going to set x equal to 0, and that tells me that there is an x-intercept at the origin. Then I'm going to set x plus 6 equal to 0. I would subtract 6 from both sides to eliminate it on the left. That means x equals -6, so the other x-intercept is at -6, 0. If you have any questions about factored form vertex form, or standard form quadratic equations, please use class time to ask for further clarification. Which equation is represented by the graph? So if you notice, all four of our choices are in vertex form. And vertex form is y equals a times x minus h squared plus k. So as we start filling this out, we notice this opens downward. So if a is negative, the graph opens down. So now I know I need negative 1 for my A. That means it cannot be choice A and it cannot be choice B because those both open upward. Now I need minus H. And we can see right here H is negative 3. So minus negative 3 becomes plus 3. Then we have K. And right here they tell us K is negative 1. So plus negative 1 becomes minus 1. And if you notice, we have the wrong symbol for 3 on D and the wrong symbol for 1 on D. So it cannot be D. C is the correct vertex form quadratic equation to represent the graph that is given to us. If you have any questions about how to determine the vertex form of the equation by looking at the graph, please use class time to ask for further clarification. For each equation, write the coordinates of the vertex of the graph that represents the equation. So remember, vertex form is y equals a times x minus h squared plus k. And your vertex has the coordinates h, k. So as we look at these, for number 1, the coordinate is going to be 3, 5 minus h plus k. Number 2, we would have negative 7 because it's minus h, and 3 because it's plus k. Number 3, minus h means we have 4, plus k means we have 0. Number 4. We have minus h, which would be 0, plus k, which would be negative 1. Number 5. Minus h would be negative 1, plus k would be negative 5. And number 6, minus h would be negative 1, plus k would be negative 5. If you have any questions about how to identify the coordinates of the vertex from a vertex form quadratic equation, please use class time to ask for further clarification. For each function, write the coordinates of the vertex of its graph and tell whether the graph opens up or down. So remember that vertex form is y equals a times x minus h squared plus k. Remember, if a is positive, the graph opens upward. If a is negative, the graph opens downward. And the vertex is at coordinates h, k. So this is the information we will use to fill out this table. So if I want the coordinates of the vertex, then it's minus h, which means h is 4. And it's plus k, which means k is negative 5. And to know whether it opens up or down, I look at A, and A is positive 1, so this opens up. Next, we'll look at G. We have what would be x minus 0, so h is 0. Then we have plus k, so k is 5. And we have a negative 1 as A, so this opens down. And finally on H, we have minus H, so H would be negative 1, and plus K, so K would be negative 4, and we have an A that is positive 2, so this opens up. If you have any questions about how to use the vertex form quadratic equation to determine the coordinates of the vertex or whether the graph opens up or down, please use class time to ask for further clarification.